Today we're going to be talking more about inverse trig functions. So your first question says list 5 values of theta in radians that would make the following equation true. The sine of theta equals 1/2. So remember the sine of an angle, when we're talking about the terminal point at that angle on the unit circle, we have your x and y coordinate and the sine is your y coordinate. So what values of theta or what angles do we know have a y value that is 1/2? So I can think of a few when we're asked for 5. So I know that when I'm on the unit circle, the first one that comes to mind is pi over 6, which has the coordinates √3 over 2, 1/2. So we could say pi over 6. But we also have over here 5 pi over 6, which has the coordinates negative √3 over 2, positive 1/2. So 5 pi over 6 would be another angle that makes this equation true. And then any angle that is coterminal with those two would also make this equation true. So for instance, 13 pi over 6, which is coterminal with pi over 6. Or if we added 12 pi over 6 to 5 pi over 6, we could say 17 pi over 6. Or there's many others, maybe a negative 11 pi over 6. So all of these, if we plugged them in and took the sine of them, we would get 1/2. Another way for me to ask this same question is if we wanted to take the inverse sine of 1/2 and we would be left with theta. This is how we were isolating theta in problems where we were solving, for instance, if I gave you a triangle and it was a right triangle and you were looking for an angle and I gave you, for instance, that this side was 5 and this side was 9, then we could say the sine of theta equals 5/9. And then we would take the inverse sine of both sides in order to find theta by itself. So this is the inverse function that we're utilizing here. But what I want to point out to you is that if we were to use your calculator is going to give you one very specific answer. So although we know there are many angles whose sine is 1/2, you're only going to get the one answer. So go ahead, if you don't have your calculator out already, take it out and make sure that you're in radian mode. So I checked to make sure I'm in degree right now. So I'm going to go to radians. And let's actually calculate the inverse sine of 1/2. And I get this decimal. So what is this equivalent to? Remember, we're in radians. And if I actually type in pi over 6, which was one of our options, pi over 6 has that decimal. So our calculator, even though we had all of these different options, our calculator tells us that our answer, our one correct answer, is pi over 6. So what I want to talk about is the range of answers for the inverse sine function that your calculator is going to give you. Think about your unit circle. If I lay out all of these angles over here, so for instance, pi over 6, pi over 4, pi over 3, and even pi over 2, and then also at 0 radians, all of these angles have unique sines. In addition, if I go down below this x-axis on the positive side, all of these angles also have unique sine values. None of these angles that I have drawn here would have the same sine value. However, if I gave you this angle over here, like 5 pi over 6, it would have the same sine value as pi over 6. So what your calculator is going to do is it's going to lump all of the answers within this range, this interval here. But in order to keep them all together, we're not going to go pi over 6, pi over 4, pi over 3, pi over 2, and then jump down here to 11 pi over 6 or 7 pi over 4, because those are apart from each other. So it's going to group all of these together, and it's going to give this as negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2, since these are all back to back without any gaps. So your range of answers in radians for any inverse sine function, so if you type the inverse sine of something, whatever that something is, then you're going to get answers between negative pi over 2 and positive pi over 2 if you're in radians, which we of course know that's equivalent to negative 90 degrees to positive 90 degrees. So for instance, if you said what is the inverse sine of, let's say, root 3 over 2, you're essentially asking what angle has a sine of root 3 over 2? Well, it's only going to give you one of these answers here. So if I think about what is the one angle within these ranges that has a sine of root 3 over 2, the one answer would be pi over 3 if we were in radians, or that would be 60 degrees if we were in degrees. And you could check that. Go back to your calculator and let's check it in degree mode just because that seems to be a little bit easier versus trying to figure out which decimals we're getting. So if I quit and I go to the inverse sine of the square root of 3 divided by 2, and I hit enter, we get 60 degrees. That's the only answer that the calculator gives. So just like the inverse sine function has a very specific range of answers in your calculator, so does the inverse cosine function. Now in this case, in order to have all unique answers, we're talking about, since cosine is your x value, all the angles that would have unique x's. So pi over 6, pi over 4, pi over 3, and pi over 2. And then all of these x values that would be below, they would repeat x values that were up here. So we have to actually go this direction. So 2 pi over 3, 3 pi over 4, 5 pi over 6, and then all the way up to pi. So it's actually going to go from 0 over here up to pi. So for our range in radians, again, it goes from 0 to pi. And the reason is all of these angles have terminal points with a unique x value. None of these angles have an x value that repeats. Therefore, in degrees, this would go from 0 to 180 degrees. So if I asked you the inverse cosine of, let's say root 2 over 2, then the only answer that has an x value with a positive root 2 over 2 between 0 and pi would be pi over 4. Or if we were in degree mode, we would say 45 degrees. And that's the only answer that we would consider correct from our calculator. So then the last one is the inverse tangent function. And the inverse tangent function has basically a very similar range to the inverse sine function. So we're actually going to cover these two groups of angles in the first quadrant and the fourth quadrant. So pi over 6, pi over 4, pi over 3, pi over 2, and 0, and then going backwards into my negative angles, negative pi over 4, negative pi over 3, and negative pi over 2. But the interesting thing here is if you try to take the tangent of pi over 2, it's undefined. Because remember, this has the coordinates 0, 1, and tangent is y over x, so you'd be dividing by 0. So we can't take the inverse tangent of pi over 2 or negative pi over 2. So instead of us having brackets around negative pi over 2 to pi over 2, we're going to use parentheses. And same thing in degrees, we're going to go from negative 90 degrees to positive 90 degrees with parentheses. So if I asked you the inverse tangent of, let's say, the square root of 3, well, we're only going to get an answer between negative pi over 2 and pi over 2, or negative 90 degrees and 90 degrees. So we would have to go through and either think through these, right? So it's positive. That means that I'm looking for an angle in the first quadrant because I know tangent is positive there. And then I would have to think about, well, this is root 3 over 2, 1/2, and this one is 1/2 root 3 over 2. Well, it's y over x, so I know root 3 over 2 over 1/2 is a positive root 3. So that means my answer is going to be pi over 3, or 60 degrees. So what I want you to do is I want you to practice this, and I want you to not use your calculator, but I want you to answer these questions as if you are a calculator, meaning you only have one right answer, and your answer has to fall within the different ranges of the inverse functions that we're looking at. So if I ask you for an inverse sine of something, then your answer needs to be between negative pi over 2 and pi over 2, or negative 90 degrees and 90 degrees, depending on what I ask for. So I want you to give degree answers for our even problems. So 2, 4, 6, and 8, I want degree answers. And then for radian answers in odd problems. So I want these answers in radians. I'm going to ask you to pause the video, or if you want me to walk through, you can listen for another minute, but I want you to try them on your own before you check them with my key. So I'm just going to pick a random one. So let's say if I wanted the right here, number 3b, this is in radians. So I want the inverse cosine of root 2 over 2. So the inverse cosine of root 2 over 2. Well, remember for cosine, we want that our answer has to be between 0 and pi radians. So that means I need to figure out the one angle between that range that has an x value of root 2 over 2. Well, we know that that's going to be pi over 4. Or let's look at this one, the inverse cosine of 2. Well, again, our cosine goes from 0 to pi if we're in radians. So is there a cosine that has, or is there an angle that has a cosine of 2? There's not. So in this case, you would write undefined. So take a minute, see if you can go through and find some of these answers like we did through the notes, and then come back and check. So here are the answers that you should have. Check those. If you have questions and you are done with the quiz and everyone is done with the quiz and you're allowed to talk, then you may talk with your peers and help one another out if you need any help.